Hello, everyone. We are back with another round of Turing Mock Interview series. I am Jose, tech lead at Turing, and I'm from Montreal, Canada. And at Turing, I work hiring the best engineers by helping them with the vetting process. And I have more than 17 years of experience, and my expertise lies in JavaScript. So today I'll be interviewing Faisal for the role of an experienced backend developer, okay? And stick until the end because this interview will blow your mind, okay? So first of all, hi Faisal, how are you doing? How is your day doing so far?
Yeah, I'm all good. It has been a great day so far. How are you doing, Jose?
I'm doing great always, believe me. Thanks for asking. So Faisal, could you please introduce yourself and tell me a little bit about your professional experience, okay, your background, and then I'll take from there.
Sure. Jose, I'm Fazil from Pune, India. I am a Google certified associate cloud engineer and a full stack developer with 5 years of experience in designing, developing, and deploying scalable, highly available, and secure applications on Web 2.0 and Web 3.0 technology stack. I have solid expertise on Web 2.0 technologies such as React, Angular, Node, MongoDB, and SQL. Moreover, I have got hands-on experience on Web 3.0 technologies such as Ethereum, Polygon, Solidity, and IPFS. I am looking forward to work in a fast-paced startup environment where I can leverage my experience and expertise to create products that scales, adds value to human lives, and create revenue streams for the organization.
That's awesome, man. So
Yeah.
thanks for sharing. Okay, I'm glad that I'm your interviewer. I already checked your profile. I already checked your test. That's why we do here. Okay, before we go to an interview, before we check every candidate's profile, tests, anything you have done at Turing, I check it before. Okay. All right. So your background, as I said, look amazing. Could you please tell me a little bit about some exciting backend projects or any kind of project that you have worked on?
Sure, Jose. Well, I've worked on more than 10 projects in the past 5 years. But in the interest of time, let me talk about one of them, which I found the most interesting and the most relevant one for this position.
Great.
Recently, I got an opportunity to develop a cross platform application for an American client in the domain of automobile servicing. It was a team of 15 members where we created modules such as user authentication, scheduling automobile servicing appointments with pickup and drop off, tracking service history of a vehicle, nudging users so that they would be sending their vehicles for servicing at regular intervals.
Mhm.
In this project, we used the power of React and React Native to develop a cross platform application which was accessible both as a web application and in the form of mobile app. In the backend, we used Node.js and MongoDB and deployed the entire solution on Microsoft Azure. With these technologies, we were able to provide dynamic scalability, business continuity, and low operational cost to our clients. Well, that's one of the projects that I recently worked on, Jose.
Cool. And believe me, when I hear low operational costs, I love it. And I'm pretty much sure they love it as well, right?
Absolutely.
And I have a follow-up question for you. So
Sure.
why did you choose this tech stack? React Native, Node.js, MongoDB, and Azure.
Sure, definitely. Let me go one by one for each one of them. So one of the major reasons for choosing React and React Native is that we wanted to create a cross-platform application. And because our view layer was different in the case of web and mobile, however, the logic behind the view layer had to be shared. So React and React Native, between React and React Native, what we did is we created a shared library that was used in both the web application as well as in the mobile app. And that is how we reduced the amount of time and efforts that went in to create the front end. And we brought in reusability by using React and React Native. Talking
Cool.
about, talking about Node.js, one of the major reason why we picked up Node.js is because of its scale and it gels up very well with MongoDB. Now, in addition to that, the reason why we chose MongoDB was it provides horizontal scaling using sharding out of the box. So that was one of the major reasons why we chose Node.js and MongoDB in this particular case.
Cool.
Moreover,
no, sorry, go ahead. Keep doing.
Moreover, since our company was a Microsoft Azure partner, we chose a Microsoft Azure Cloud Platform, and it also reduced the cost for the clients since we were a partner of them.
That was interesting answer. So I'm gonna ask you later on how you guys scale up your Node.js application? How did you scale your Mongo database? Okay, but for now, okay, let's stick on the back end. And what are some of the best practice, okay, that you are using for, I would say, performance in testing?
Sure, that's an interesting question. And I've seen many teams delaying performance testing, but that is the first testing that I feel should be performed in any application, right? So let me talk about some of the performance testing techniques that we recently used on the automobile servicing project. Mm-hmm. So the client, being a startup, was unsure of the load that the system should be able to handle from day one during the normal and the peak traffic hours. And hence we had to come up with the assumptions of queries per second and requests per second based on the market area that the client was willing to cover. So let me talk about a couple of aspects and the best practices that we considered while we were performance testing this application. First and foremost, we created a separate performance testing environment on Azure Cloud with configuration similar to that of a production environment, where we had multiple read replicas and a write DB. Moreover, we leveraged the power of Azure serverless functions to ensure that the application logic has dynamic scalability out of the box available, and also to ensure that the business logic layer never bottlenecks the entire performance of the application. Moreover, we deployed load balancers to ensure that the load is approximately evenly distributed amongst all the service instances, also to ensure efficient utilization of available resources. Finally, we used JMeter to track the performance of the application and tweak the architecture to meet the assumed queries per second and requests per second of the system. Well, that was all about performance testing that we did there.
Cool. And so in your experience, what is acceptable in terms of requests per second?
Well, that finally boils down to the amount of users that we are expecting. And the request per second and queries per second, you can take it to a higher level based on the amount of users. But when you take it to a higher level, you would also be incurring more costs, because based on that, you'll have to scale up your application layer as well as your database layer. And hence, we have to go case by case basis rather than aiming for a fixed number. I mean, there's no one shoe fits all number for queries per second and requests per second, is what I believe.
Cool. All right. So my next question for you is, how did you scale up your Node.js application in that project that you mentioned?
Sure. So first and foremost, we used the dynamic scalability, which is available out of the box when you go with a platform as a service solution, which is provided by Microsoft Azure. Serverless functions is what we call it. So when we talk about serverless functions, the developers need not worry about the deployment. We only worry about the application code, and the cloud provider, in our case Azure, takes care of providing dynamic scalability and also having pre-warmed up instances of those services to ensure that we are able to serve the peak hours of traffic. Talking about the database layer of scaling, MongoDB provides sharding out of the box. By sharding, I mean to say we can horizontally scale a MongoDB database by using the correct shard key. So let me give you an example of how we horizontally scaled the servicing history details. So the way we sharded the data was based on the state in which the car belonged to. So we had multiple shards of database, each storing the servicing history of cars, belonging to a given state in America. Right. So that is how we horizontally sharded the entire database of car servicing. The benefit that we reap out of it is that one single database would be having lesser load, and the load would be equally distributed amongst all the available databases. So that is the benefit that we reaped out of horizontal scaling in MongoDB. In addition to that, to scale up reads, we also created multiple read replicas to ensure that one database is not being hit for both read and write queries. So transactions would be handled by one database and read queries would be handled by the read replicas, which is available in MongoDB.
That's cool. Yeah, you just killed my next question. Okay, how do you scale up that? But yeah, I'm glad that you mentioned. So basically, this master, we work with master and we work as a proxy, right? And then you have slaves, and then all write request goes to one server, and the read one goes to the next one, right? Go to the slave ones. Yeah. You just killed my next question, but yeah, I'm glad for that. So what do you understand by a CID property of a system?
Oh, great. The term ACID refers to atomicity, consistency, isolation, and durability of a transaction that occurs in a database system. Let me talk about each one of them in detail.
Yes, please.
Atomicity guarantees that if one of the transaction fails or one of the queries which is a part of the transaction fails, the entire transaction should fail and the database will be reverted or rolled back to a previous state. Whereas consistency ensures that after performing a transaction, the database will always be in a valid state as per the constraints enabled in the database tables. Moving forward, isolation ensures that concurrent execution of transactions result in a system that would be obtained when the same set of transactions would be executed sequentially. Finally, durability makes sure that if a transaction has been committed, it will always be available in the database, irrespective of a catastrophic failure, such as a power loss or network issue. Well, that was all about ACID properties of a database system.
Cool. And you mentioned catastrophe. So here, in my case, it would be a snowstorming. Yeah. All right. And you mentioned layering your application several times. Okay. So what do you mean about layering your application, and why layering your application is important? And also, could you provide some good and bad examples?
Sure, definitely. So layering, in my opinion, is of absolute importance. And it is very important when it comes to backend applications to ensure separation of concerns, unit testability of the code, and reusability of the code as well. One of the most common layering approach is to divide the application into controller or the routing layer, services or the business logic layer, repositories or the data access layer. Now, let me talk about one of the APIs that we had to unfortunately refactor as it did not follow the correct principles of layering. So there was an API to fetch the car servicing history details, to fetch the previous services that a car has went through and their respective service centers. It was mainly used for reporting purposes. So the developer who developed this API earlier assumed that it would always be used by a REST client. And then he made a mistake of returning HTTP responses such as 500, 200, 201, etc. from the business logic layer. Now, later there was a requirement where an internal API wanted to access the same API, which was used to fetch the car servicing history details. Now, the problem happened because the internal communication between API to API happened via gRPC protocol, whereas if you remember earlier, the developer had hard-coded HTTP status codes in the business logic layer. Now, in order to ensure that we were able to reuse the same business logic layer for the gRPC client as well, we had to abstract out the HTTP status-related code from the business logic layer, keep it in the controller, and hence enable reusability by ensuring that the same business logic layer is being used by a REST client as well as a gRPC client. Hence, I always consider low-level design and spending some efforts in low-level design to ensure that the layering is thought upfront rather than thinking at a later point of time.
Okay, and then did you use any design pattern like PubSub or how was the communication between your REST API and your gRPC application?
I remember one of the occurrences where we had used PubSub. So there were webhooks in order to receive events from a third party. So whenever we used to receive this webhook, we used to have an event emitter, which would emit an event, and there was a subscriber who would always be listening to that event and logging webhooks in the database table. So this is one of the occurrences where we have used a PubSub pattern in our application. I hope this answers the question.
Yeah, you did. I'm not going deep on this question today. Okay, yeah, I'll just give you a tip for our audience. So if you want more question for design pattern, so leave a message in the comment section below. We're gonna make a video for you. Okay, explain design patterns, so system design as well. If you want it, you just need to drop a message. I would like to also call upon our React developers, our backend developers, front-end developers, fellows here. If you want to get a remote job, my tip for you is go to turing.com/jobs, okay, and apply for the job that that is more suitable for your tech stack. Okay, go turing.com/jobs, search for the job by tech stack, and apply for it. So once you are applying, you just need to pass through the vetting process, and then you'll get a remote job, as we did. Okay. One more thing. So if you are enjoying this content, please consider to give us the big fat thumbs up for this video, and comment in the section below what is your answer, if you would answer it in different way. Okay, subscribe to our channel if you are not subscribed already, and let's go back to you, Faisal, and then let me talk more about the background, or talk more about database. Okay. You mentioned sharding, what was great, but I would like to ask you about index. Okay. What do you understand about indexing, data indexing and database?
Sure. So indexing, one of the major reasons why one would index data in the database is to ensure that the search is efficient. So let me talk about different indexes that are available in the database. If I remember correctly, we have clustered indexes and non-clustered indexes. So when a clustered index is applied on a table column, it ensures that the rows are physically stored in the database in a sorted order of the indexed column values. I'm sure you must have seen that whenever we apply a primary key on a column, the primary key column is automatically considered as a clustered indexing column. And whenever we retrieve the value from the database, it would always be in the order of primary key column by default. And hence we need not apply any sorting on primary key whenever we retrieve the data. On the other hand, when we talk about non-clustered indexes, when non-clustered indexes are created on a table column, it creates a separate table with the sorted values of the indexes and a pointer which would point to the actual physical row. So let me give you an example. Let's assume there's a table of students with ID and name of the student. Here, ID would generally be a primary key, which would be considered as a clustered index.
Yes.
And on the other side, let's say there's a requirement to search the students by name. So we can create a non-clustered index to ensure that the search by name is performed in an efficient manner. Yeah, that is how I've used indexing in couple of projects of mine. I hope this answers the question. Yeah.
No, you did. And so let me just give you more examples. So let's suppose I update this table, okay, and I add email there. And now we have ID, name, and email, right? And then I would like to, then the email is unique, okay, which another kind of index, right? So the email is unique. The name could repeat, so we could have 10 Faisal in that table. And I would like to search, okay, for name and email, okay, and then my query starts getting slow, okay. What are the reasons for that, and how could we debug it and also improve it?
Yeah, one of the ways that I can see the query to improve in this particular case is by making a composite index that could be applied on a group of columns, right? So this is something that I can remember creating a composite index if you want to improve the query performance of multiple columns or a group of columns in a given table.
Cool. And is it considered a cluster index or no cluster index?
It would definitely be a non-clustered index.
For sure. All right, great. So next question. What's the difference between where and having?
Oh, that's an interesting one. So where clause is generally used to add condition on rows in the table, whereas having clause is used to add conditions on the aggregations which are obtained out of those rows. Let me give you a business requirement where we have used both where and having together along with group by. So there was a business requirement where we had to fetch the brands of the cars whose mileage is greater than 10 miles per liter and their average yearly maintenance cost is less than 1,000. In this scenario, where was used to filter out cars whose mileage is more than 10 miles per liter. And then we use group by to group the brands, and we use having using the average as the aggregator. So we use having with the average as the aggregator to calculate the average cost and then pick up only those cars whose average yearly maintenance cost was less than $1,000. So this is how we use where followed by group by followed by having to get those brands satisfying the criteria.
Cool. And then I have more questions regarding where. Okay. What's the difference between where and on in SQL?
Okay, that's again an interesting one. So people generally confuse between where, on, and having in SQL. So on is used to define join condition on the tables, whereas where clause is used to define filter criteria on those joined rows. Yeah, in case of inner join, both where and on can be used interchangeably. But in my opinion, for the purpose of readability and accuracy of results, we should always be using on to join the tables. I mean, to provide the conditions for joining two tables, whereas filter should always be, where should always be used to filter the joined rows. Well, that is the difference between on and where in SQL.
Cool. So let me share my screen. Okay. And then I will show you two examples and then I will ask you to explain me. Okay.
Sure.
All right, Faisal. So here I have two SQLs. Okay. I will explain to you. Okay. And then I will ask you one question related to that. Sounds good?
Interesting. Let's go.
All right, great. So here I have this table user where I'm getting everything. Okay. Okay, better than that. Could you please explain me what I'm doing here?
Yeah.
Let's start with the first one.
Sure thing. Yeah. So in the first query, as I can see, we are selecting all the columns from the user table. Yes. And we are joining it, specifically doing an inner join with the dependence table where the dependence user ID is equals to user's ID. Basically, there's a primary key foreign key relationship. Yes. In the dependence table from the users table.
Yes.
After joining, we are then obtaining the users whose ID is greater than 10 and their name contains Turing in it. So correct. That is what would be fetched as a part of first query.
Yes, correct. And what's about the second one?
Yeah, in case of second query, what we are doing is, so rather than joining it just based on the primary key foreign key relationship, we are also adding new conditions for join, such as the user ID should be greater than 10 and their name should have Durand in it.
Correct. Let me just change to Turing. Then we have the same results, supposedly, right? What's the difference between these two queries?
Yeah, the major difference that I find in these two queries is that the joining condition. So in the first queries, the join would be performed on the entire table first, and then the records would be fetched and filtered. But in the second case, the joining would be performed based on the entire condition that we've written there, including the and the like there. Yeah, so with this, we would be preventing the joins to be performed on extra rows.
Correct. And then we might get some different results here. Okay. The recommended one is the first one or the second one?
The recommended one is always the first one. As I mentioned, we should be using on to provide the joining condition, and we should be using where to provide the filter criteria.
Great. So thanks for explaining that. And my next question for you is related to API gateway. Okay. Could you explain me what is the API gate pattern?
Sure. So an API gateway sits between the clients and the services. It acts as a reverse proxy to route requests from clients to the APIs behind the gateway. Now, in addition to routing, an API gateway might have other responsibilities, such as authentication, monitoring, load balancing, SSL termination, request response, caching and shaping, static response handling, etc. One of the major reasons why we use API gateway is that it encapsulates the internal structure of the application and it hides it from the outside world. So when we have an API gateway, the client, that is the front end, need not know the IP addresses or the domain names of each and every APIs that are deployed in case of microservices. The client only need to know the API, the IP address or the domain of the API gateway, which then takes care of routing requests to the respective APIs. So that's the benefit of having an API gateway in your architecture.
Cool. And let's move on to database again. Okay, so you mentioned in your infrastructure you have used the Mongodb, right? And then also, what kind of cache mechanism are you familiar with?
Yeah, so if I remember correctly, we used Redis to perform in-memory caching. So Redis is an in-memory key value data store, which can be used for caching frequently accessed data. So one of the requirement was to have master data away from MongoDB. So we did not want to trouble the read replicas of MongoDB to load it for fetching master data like details of country, etc. So what we did is every time a service would spin up, it would then be loading the Redis database, the in-memory Redis database with all the master data. So whenever there's a request to fetch master data from the client side, we would always be fetching it from the Redis rather than loading up the MongoDB with those read queries, which could easily be done by a caching mechanism using Redis.
Cool. Okay, that was interesting. Okay, and so when should we use Redis over MongoDB, or should we use both? Is Redis and MongoDB a great fit?
Yeah, it is. So let's talk about MongoDB and Redis in detail, and then I'll give you an example of how we used it. So MongoDB is a schema-less, document-based permanent data store. On the other side, Redis is an in-memory key value data store, which enables faster access of data, but the storage of data isn't permanent when you compare it with MongoDB. So there was a requirement in the automobile servicing application to create leaderboards. So whoever would be servicing the vehicles and would be getting better feedback from the client, they would be awarded with a higher amount of points. And finally, those points would be converted in some dollars when their salary is credited. So in order to show these leaderboards, which are frequently accessed, but it changes every month. So what we did is we would be storing these data of leaderboards in the Redis cache rather than triggering a query in MongoDB every time someone is trying to fetch leaderboard details. So this is how we use best of both, like Redis and MongoDB together to get performance out of the architecture.
Cool. And regarding your tech stack, okay, the tech stack that you mentioned before in that project. So if Node.js, okay, is a single threaded, how does Node.js handle concurrency?
Yeah, this was one of the questions that came from our clients as well. Why are you using Node.js since it is single threaded? So the way it works is the magic lies in the way Node handles asynchronous operations, such as file IO, DNS calls, or network calls. So whenever Node gets an IO request, it creates or it puts that IO request on a separate thread. And then that thread would be performing the IO operation. And finally, once the IO operation is either completed or there's an error in it, it would be putting the event on the event queue of the node.
Mhm.
And then there's an event loop, which would keep reading the messages from the event queue. And as soon as it finds out that the IO operation is completed or any asynchronous operation is completed in the event queue, it would then continue the execution in the main loop. So that is how Node, being a single threaded, it intelligently internally creates separate threads to handle asynchronous requests.
Cool. And that was my last question for you. Okay.
Oh,
Thank you
okay.
for this really nice speaking. Okay. I hope everybody liked that as I did. Okay. And to everybody else, thank you for tuning this mock interview series alive. Okay. And we'll be back very soon with many other mock interview. Please let me know in the comment section below which kind of mock interview would like to hear from us, okay? And what kind of videos would like to hear from us as well. Just drop a message, drop a comment, and then we are going to make it for you, okay? So what else? Don't forget to subscribe to our channel and hit the like button if you enjoy this content. Let me know in the comment section below if you answer this question in different way. I would love to see that, okay? Follow Turing on Twitter, Instagram, Facebook, LinkedIn, YouTube. So we are everywhere. Okay, keep close to Turing, and I'm pretty much sure that you will find the job that you are looking for. As that said, that's a wrap. Thank you again, Faisal, for your kind words and your amazing answers. Okay, take care and stay safe and learn more. Happy coding.